Hi there, welcome to the A-Level Mathematics Tricky Exam Questions Workthrough. This is Partha Griwala, lead tutor at roarandlearner.com. So, the aim of these walkthroughs for AS and A-Level students is exercise practice is just not sufficient to get that high grade. Exercise practice is often very repetitive, it's not very similar in any sort of way to the exam. Exercise practice just builds on using one simple skill, and it just explains to students how to use that skill until they and repeats it until they become good at it. This is not what exam practice is. Exam practice is all about applying a variety of skills in particular contexts. And so we go through these exam questions normally after students have mastered a couple of techniques, or after students are have finished the entire curriculum. We like to go through these sort of walkthroughs during class and provide live feedback and live prompts to students as they work out exam questions, as well as giving students templates to use, which they can use to solve exam practice questions in their own time, and hopefully remember those templates and do really well in their exams. Particularly stats and mechanics seems to be an issue with AS and A-level students struggling. The reason for all this, we believe, is because stats and mechanics is introduced completely, it's a completely new concept introduced to students at AS and A level, and students who had previously struggled with mechanics or have struggled with basic mathematical numeracy will really struggle with these questions. So we like to go through them in class, show students what techniques are needed and how to visualize each exam practice question, and particularly understand the cues behind each exam question, because most exam questions are actually quite similar in the sense that exam practice questions for the same topic will often involve very similar methods of deduction, very similar methods of solving. So understanding how and what the key sort of hints are in an exam practice question will help students solve and become better at mathematics and achieve a higher grade. And this is what we aim to sort of go through during these exam practice questions, and also build confidence for the real exam or the prediction exam, because there's a lot riding on these exams, real career decisions on these exams. So we like to give students as much confidence as we possibly can in these sessions. So let's get started then. One of the papers I'm using, so for the first question, I'm using this paper. It can be found on the OCR website. So please feel free to solve it in your own time and look at the mark scheme. So this is the question we'll be doing. So in this question, the vector I is horizontal and the unit vector j is vertically upwards. A particle of mass 0.8 kilograms moving under the action of its weight and two forces given by Ki and 5j and 4i and 3j newtons, the acceleration of the particle is vertically upwards. Write down the value of k. So this is a very simple question, and that's why it's only 1 mark really. So the theory behind this is that you have I direction, which is upwards, and you have I direction, which is downwards. So this is j direction, which is upwards, and I direction, which is this way. Now, what this means is it tells us that it's going vertically upwards, right? There's no horizontal movement. So what we can assume is that Ki and 4i must equal to 0, right? Because there's no horizontal movement. So 4i minus Ki has to equal to 0. And so for that to happen, you need K to be equal to 4. So K is equal to minus 4, right? Because here there's a positive. So we can say K is equal to minus 4. So nice simple first question, just to test if students understand the basic theory. So now let's look at maybe the next question. Looks a bit more complicated. Let's read it 1 minute. So let me just rub this out. There we go. So nice and rubbed out. Let's have a read of the next one. So initially the velocity of the particle is 4i plus 7j. Find the velocity of the particle 10 seconds later. So students, they see these components and they become really, really struck, because they've normally been used to dealing with forces in linear numbers, not really in components, and the 10 seconds later really confuses students because they don't know how do I find it 10 seconds later? How do I find something that's been going on 10 seconds? So it's quite a simple trick, really. Generally, in mechanics, if you've been asked about time or any other variable, if you remember the Suvat equations, your initial velocity, final velocity, acceleration, displacement, and time, and you've been given the weight, normally it's something to do with Suvat and F equals ma. That's what you're normally going to have to use, okay? So how would I sort of go about solving this question then? So here, firstly, we know that the weight is going to be equal to 0.8, because that's what the mass is, times g, because that's what gravity is. If you remember, gravity goes downwards, and that exerts a force. And that's going to be in the j direction. Remember, I told you j is in the vertical direction, right? So that's what our weight is going to be. Now, our F equals ma is going to be force. So F equals ma, F equals m times a, right? Now, we know that our mass is 0.8 and our acceleration, we have no idea. But we know our forces, we know we have, and we only really need to know the forces in the vertical direction, right? Because that's the only direction things are moving, right? Nothing's moving in the horizontal direction. So we can do 5j plus 3j to give us all the sum of the forces minus 0.6, 0.8 gj. And this is going to equal to mass times acceleration, so 0.8 a. Now, we can solve this to give us a is equal to 0.2j. And now we can use Suvat, right? So if you remember, v is equal to, so let me just do this here. So if you remember in Suvat, we've got acceleration, which is 0.2j. We've got acceleration, so 0.2j. Oh yeah, also we've got initial velocity, 4i plus 7j. We also have our time, which is 10 seconds, and we want to know our final velocity, which is the unknown. So to do all of this, if you remember, we can look at the Suvat equations and ask ourselves, well, what equation has all four of these variables? And if you're good enough, you'll remember the Suvat equations by heart. And looking at the equations, it seems like it's going to be v is equal to u plus at. So v is the unknown, equals to u, which is 4i plus 7j, 7j, add at, so 0.2 times 10, and that will give you 4i. So when you simplify it, you'll get 4i plus 9j meters per second. So I hope this little question has explained to you how often it might look really scary. A question might seem, oh my god, what on earth do I do? But it's a matter of just understanding the cues, understanding the hints. What's being asked? How do I, how have they always done it? What do I need to do? What have I learned from my exercises in class? So quite simple, really. Just a bit of practice. That's what the students need, and a bit of prompting. So let's move on to the next slide then, perhaps. Let's see. So this is from an AS level mathematics paper, and so just for the AS level students, we're going to do a little exam practice question here, just to demonstrate how we might go about AS level. And in particular, we're going to look at the statistics side. So this is a stats question. So according to latest research, there are 19.8 million male drivers and 16.2 million female drivers on the roads in the UK. So a driver in the UK is selected at random. Find the probability that the driver is male. So this is quite a GCSE actually level content. So find the probability that the driver is male. All you need to do is do the total divided by, the males divided by the total. So the total is 19.8, add 16.2, which is 36. So 19.8 divided by 36. This gives you a probability of 0.55, because remember, the event you're interested in, the number of times the event you're interested in, divide by the total number of events. That's what probability is. Calculate the probability that there are 7 female drivers in a random sample of 25 female drivers. So the probability that you have a female driver is 0.45, right, out of any sort of individual chosen, because 1 minus 0.55 gives you 0.45, and you need to times that. So here what you need to do is you're going to have to the power of 7 times by binomial, so 7 and then 25, and that should hopefully yield you the answer. So I think the answer for that will be, before we actually find the answer, I think we need to also, because it's a binomial thing, we need to also do 0.55 to the power of 18. So this is some actually ES level math that's being tested here, and this should give us the right answer. Let me just chuck this into my calculator. Yeah, so 0.0381. So leaving it to 3 significant figures. So now comes I think the more tricky question that A-level students struggle with. When driving in a built-up area, Rebecca exceeded the speed limit and was obliged to attend a speed awareness course. Her husband said it's nearly always males who are speeding. When Rebecca attends the course, she finds 25 drivers, 7 of whom are female. You should assume that the drivers on the speed awareness course constitute a random sample of drivers caught speeding. Conduct a hypothesis test to determine if there is any evidence that at the 5% level to suggest that male drivers are more likely to exceed the speed limit than female drivers. So these kind of questions, you really have a template you just need to follow. So normally there is a null hypothesis and a alternate hypothesis. So if I start writing this here, so you have null, which is your H0, and here your null hypothesis is that the likelihood, so the probability that this has happened is equal to 0. So the probability that null hypothesis means there's no difference, and there's actually no difference whatsoever. So the probability that a driver is speeding or is caught speeding is 0.45. This means that the probability that the driver is a woman and has been caught speeding is 0.45, which means that there is no difference actually between a female driver and a male driver and the likelihood they'll speed. Because if you remember, the probability a woman drives is 0.45, right? So the likelihood they get caught is also going to be 0.45. However, the alternate hypothesis, which is what Rebecca's I think husband is saying, is P is less than 0.45, which means that if you remember, the likelihood a woman gets caught, if all is well and all is equal, is 0.45. But if it's less likely for a woman to be caught speeding and more likely for a man, the probability a woman will get caught is less likely, right? So it'll be less than 0.45. So now we have our H0, H1, and we need to state that P is likelihood. So I'm not going to write the whole thing out because we'll be here forever. So it's the likelihood that a woman will be caught speeding. That's what I would write. And this is actually like 2 or 3 marks right here. So then you need to actually calculate what is actually the likelihood that what's actually, so you need to use your binomial. So binomial, so you've got 25 trials, and each time a female happens is 0.45. So remember, this is number of trials. This is number of successful. Yes, successful. The probability of an event happening successfully is 0.45. So now we calculate the probability of these events. So the event is a woman being caught speeding, being so x less than or equal to 7 times. Now, students always ask me, why don't we just calculate the probability x, so x being the likelihood a woman gets caught speeding, just is equal to 7? Because with null hypothesis, you'll want to know what's the likelihood of this event or a more extreme event happening, or more extreme happening. That's what null hypothesis is about, and this is something we go through when we're doing stats as well with the students. But we will go through this bit in a bit more detail maybe in class as well. So the probability of this happening, that you have, so we're doing the sum total probability, right? So probability x is equal to 1, probability x is equal to 2, 3, 4, 5, 6, 7, and we're adding them up. And this will give us 0.06385. So we leave normally things to 4 decimal places or 4 significant figures, just because rounding off early in an answer will give it a very inaccurate answer. So now this is the probability that you might get 7 or less, 7 female drivers, or 6, 7, 5, 4, 3, 2, 1, and that's a probability. And remember, our cutoff was 0.05. So another mark is just for writing down 0.06385 is greater than 0.05, which is our significance level. So just writing these things down. Yeah, students forget to write down this. They also forget to just write down the binomial distribution, they've used that, or the probability of calculated that, or that this is 0.05. That's a lot of marks. It's like 5 or 6 marks already that they might have lost if they didn't write this down. And then you need to say, okay, so the result is insignificant. So I'm not going to write it down. I'll just say this orally, but you should write this down really. I haven't got a writing tool here. But result is not significant and accept null hypothesis, as there's insufficient evidence to reject the null hypothesis. So you never accept, there's never going to be evidence to accept the null hypothesis, because you don't have anything backing the null hypothesis. You just don't have anything backing the alternate hypothesis. You just don't have enough probability values. That's why we are rejecting the alternate hypothesis, accepting the null hypothesis. There's just not enough evidence for the alternate. That's why we accept the null. So I hope this has made hypothesis testing a little bit clear, and how to structure the answer a little bit more clear, because students struggle structuring answers here. And this is something we'll often go through in class with students, because it's an essential skill. These kind of questions just keep coming up in AS level content. So if you've enjoyed our tutorial, please subscribe to quench your thirst for learning. At Roaring Learner, we have a very big thirst for knowledge, and we'd like to share that with our students. So please subscribe for our one-on-one or group tutoring packages. Thank you for listening.